Well, yes, it would help if I unmuted my microphone again. Okay, we're back, and minor technical hitches aside, we are making good progress, I hope. So yeah, I want to do one more thing to this. We've got our envelope shape, but one more thing I want to do with before we leave this part of it. Sometimes you would like to make some kind of drone noises, and I've seen some other synths that do this. I didn't used to quite see the point, but now I think this is quite a useful facility. So I'm going to add the facility to mix the enveloped sound with a non-enveloped sound. So, as is always the case, we will break that, and we will take this is the sound that's enveloped, but we will sum together. Okay, we will sum together the enveloped sound with the non-enveloped sound, but we want to have a mix of those two. So we will add here two more boxes. Again, amplifiers. We're mixing basically. So we're going to have that one there. We're going to have that one here. So this signal on the right, let me just pull that up a bit more, is the mix of how much of the sound that has come through the envelope shaping. Over on the left, we're going to have a bypass that comes through this, and then the two will get mixed back together. In fact, we don't need this anymore. We can feed them both into here. So what we would like now is to control we would like these two, the volume here and the volume here, to add up to 1, right? So we will create ourselves a new slider, and we will just call this something like, that's the quantity of envelope we're using, and that's going to be between 0 and 1. Give that a box as well. So when it's 0, we're using no envelope, and when it's 1, we're using full envelope. So here I will multiply that. So when the envelope, this slider is over on the left, it's 0. This is going to be 0 coming in here, and the amount of sound coming through the signal coming through this channel through the shaped envelope is nothing. When the slider is over at the other end at 1, we want this to be 1, and so a full amount of sound coming through here. And of course we want the opposite in the other side. Now, how do we so we would like it to be the equivalent of 1 minus this value. Now, the easiest way, or the way that doesn't introduce any new complexity, is I'm going to multiply it by -1 to get the negative version of it, and then I am going to add 1. So if we just confirm what we're seeing here for a second, this box here is the amount of envelope we're using. This box is the amount of envelope we're not using, if you see what I mean. So here, as you can see, when this is on the left, this is 0 and this is 1, and as we go across, when that's 1, this is 0. So that's what we needed, and we now just connect that to this side of the signal. So if we come back out of here again, right, okay, so if we see the slider over here, no envelope, all of the signal is coming down this left side, and there's the envelope is being ignored. The slider over here, nothing is coming down this side, and everything is coming through the right hand side, through the envelope shaping. As you can see, if we're over here and we click that, it makes no difference. If we go somewhere in the middle, maybe just a bit further, you still get the effect of the envelope, but you don't get so much. So that gives us a certain amount of flexibility. We can either have no envelope, which means we can go back to using this as a sort of drone synthesizer, or we can have full envelope and just play notes. But we can also have an interesting mix where a little bit is behind, is kind of, the drone is coming through, but the envelope still gives a very prominent boost to it. And I think that's quite a useful, it's quite a useful extra feature. So that's it, this part is now over. So welcome back. I've just been tidying up where we were, our work in progress, and we've reached phase 3 of our synthesizer, where we're about to build our simple sequencer. But just to confirm, here's where we are. There is our thing. I've encapsulated all the envelope stuff into this new object. Let me just show you that again. I click there, it opens up what we put inside it. It's a bit messy, I didn't tidy that up, but you can see that those inputs to it have become what's called an inlet, and the outputs go to what's called an outlet. We won't worry about that at the moment, but just remember that what's inside this ADN is the envelope stuff we've been developing in the last couple of videos, or the last couple of sections, chapters of this. So I've done that, I've shrunk it a little bit, I've tidied up a little bit, and we are now ready to start looking at how we can build a sequencer, a fairly simple step sequencer. And yeah, we're still making noise. So the beginning of this is an object called a metronome. The metronome, and that takes two other objects. That takes inputs from something called a toggle, which is like an on-off switch, and something, and another H slider. We'll make the H slider between something very slow and very fast. So let's say, I think this is in milliseconds, so it's 1,500, so 1.5 seconds down to 1,000th of a second. The toggle will go into this first input, the slider will go into the second input, and then on the metro we will add something called a counter, which obviously takes the regular pulse that comes in from the metronome and starts counting, and we'll see what it's counting when we put in this number box. So let's just have a quick look at that. We'll set the metronome to, actually before that we'll give this a number box as well. I say I think this is in milliseconds, so okay, you can see this counter going up here. Let me slow this down. Yeah, the slower we get, the longer we wait between each tick. If we go up here, the counter is increasing very quickly. So that's metronome is producing this regular tick. The counter is simply taking a number and incrementing it every time a tick comes in. However, we will do an 8-step sequencer just as a simple version of this. So we want to be able to count not numbers of any size, but we want to be able to count the numbers effectively from, well, typically we will count the number from 0 to 7. It's 8 steps, so it'll be 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. For that, we use an object function called modulus. So it's a mathematical function. You represent it typically in programming with a % sign, and we're just saying modulo 8. So what are we doing is we're dividing by 8 whatever the number coming out of the counter is, and the number coming out of the counter continues to be 3,027,000 or whatever. We divide it by 8 and we take the remainder. That's the modulo. And if you're dividing by 8 and taking the remainder, then obviously that number is always going to be between 0 and 8. And we'll show that again here. Just run that, start that, and you can see we're counting up. And when we get to 3, 4, 5, 6, 7, no, 3, 4, 5, 6, 7, we just go back to the beginning again, which is exactly what we need. So, what are we doing now? Well, we now want to control this pitch from the sequencer. So, we will do exactly that. The next object we want is an object called a select, and this object will select, is sort of the opposite of the pack. It's going to take something in and, well, depending on the values, it will send a signal out of one of several outputs. In fact, in this case, we're going to give it 7 or 8 outputs between 0 to 7, and you'll see it's indeed given us those 7 outputs. Those are each going to trigger a number box. So I'm now going to put in a set of number boxes. Eight number boxes. No, I don't want to connect it. It's convenient to connect to the previous one when you want it to be, and it's a nuisance when you don't want it to be. So, 8 values here, which can be anything we want. Let me just shuffle those upwards a little bit. And okay, these could just be piped straight into the pitch, but remember the pitch is in hertz. Let's now move to using MIDI, and so we will, okay, so the first things first, we will connect the select to each of these number boxes. So depending on the value coming in the counter, from the counter, which is the numbers 0 to 7, it will select one of these first 8 outputs of the select box and fire the signal out of that. So if the number 0 comes in here, then it's going to be this that's fired. The signal is coming down here. If the number is 4, then it'll be near 1, 2, 3, 4. It will be this one that's fired. Okay, and only one of these at a time. All of these now will put inside another object called M2F. M2F is a simple conversion of MIDI note value into the appropriate frequency. So we can now highlight all of these and we can drag into there, and you'll see that it's actually made a connection from all of those into the MIDI to frequency. And now we can connect the MIDI to frequency into the pitch slider. So at this point, every tick of the metronome, the counter increments, but we get out of this modulo 8 the remainder from dividing that number by 8. So the numbers between 0 to 7. That number comes into the select box, and depending on which number it is, we get a trigger coming out of one of these first 8 outputs. Those in turn go into these 8 number boxes, and in a minute we're going to fill the number boxes with some values, MIDI note values. Those, whichever is triggered, will come into the MIDI to frequency, and the MIDI to frequency will send the frequency to this. We're not quite there yet, because if you remember, our envelope is triggered by this, and what we would like is a similar output from our metronome to that. So now the metronome, every time it pulses, as well as sending this information through these, to take one of these boxes and send it into the pitch here, is also going to pulse the envelope. And so let's hear how that sounds. Take the frequency down. You can hear, of course, what's the pitch? The pitch coming at the moment is very low because it's 0. But if we were to now increase one of these numbers, as you can hear, every time it hits that MIDI note 67, right, so if we now make that we will just, I'm trying to make a simple chromatic scale here. Should be possible to type these in, actually. I don't know if it is or not. But we can hear the principle, right? We can hear that, and we are now getting a note for each of these. And of course we can speed that up. And now we can start playing with the various parameters . We can make it fast. And now you can hear, because we're continuously triggering new notes the whole whole time by changing the pitch, then now the changing the amplitude, the ratio, the effect of that is noticed very quickly. We reduce the amount of envelope. Now here you can see as well that having a mix of the envelope and not envelope gives you certain qualities of your sounds. And as we start playing now with our parameters, so it wasn't hard to add a simple sequencer to this, but let's perhaps make the sequencer a bit more flexible in some ways, because we would like to have the capacity not just to set these absolute notes, but have a, well, I will show. Instead of going from the absolute values of those, what I prefer to do is to have a plus, have another slider here, which we will put the equivalent of our root note. Let's call it 0 to 127. And we will take the output of the root and we will add it to that value. So instead of having, you writing those in absolutes, we can now write these as relative to whatever our root is. So let me just show you what that means in practice. I'm putting these numbers, we'll put a number box there so you can see what the actual note is, and of course we need to still put that through a MIDI to frequency. Gets running out of space here a bit, but let's pull that down to 10, 4 and 5. Okay, so if we were to start now, so the value coming out of here, we still need to connect the output of this to the pitch. Right, it's still very low, but let's put this up higher. So this is now relative to whatever that note is there. So these are the absolute notes coming out, but we've managed to make a sequence and now we can start imagining you'll hear there that we seem to be hitting a limit, and of course where's that limit from? Well, that limit was when we set this pitch originally, we gave it a maximum frequency of 1,000, but now we might need to go higher. So let's give it a maximum frequency of 4,000. And now those higher pitch notes start to become audible again. And you hear we're getting some interesting kind of sub artifacts there. So yeah, that's how we added a fairly simple sequencer, 8-step sequencer to our synthesizer. And now I hope you can see how you would be able to use this instrument in a performance, or certainly record some sequences which you can use with other, in a musical context. So we're getting close to the end here, but I've still got a couple more things to show you, and we'll finish this chapter here and move on to the next one.